20. A block is released from rest at the top of a hill of height h. If there is negligible friction between the block and the hill, the block arrives at the bottom of the hill with a speed v. The block is released from rest at the top of another hill with a rough surface and height h. If 1/2 of the initial mechanical energy of the block Earth system is lost due to friction, as the block descends the hill, the block will reach the bottom of the hill with a speed of... In the first case, all of the potential energy is converted to kinetic. So we have K is equal to 1/2 mv squared, or V is equal to the square root of 2 times K divided by the mass. In the second case, only half of the potential energy transforms to kinetic. So we have 1/2 K is equal to 1/2 mv2 squared, which turns into V2 is equal to the square root of K divided by the mass. If we take the ratio V2 over V, the ratio simplifies to 1 over square root of 2. Or V2 is equal to 1 over square root of 2 of V, which represents, of course, option C.